Hello, everyone, and it's truly an honor to have you all here. I'm here to talk about OrchestrAI, a project we built in MHEX 8, the largest student hackathon in the USA, and who actually won the first prize. But before I start talking about the project, let me introduce you to the team who actually built this. First, we have Aditya, the violin virtuoso and music theory expert, who likes to use artificial intelligence and augmented reality to deliver education to the world's most underserved populations. Then, we have Ezra. Our hardware and digital signal processing whiz, who's very interested in delivering emerging technologies to several different populations in the world. Then, we have Sarthak, our very own creative hacker, who built Argon, the first augmented reality web browser. And finally, there's me. I'm the deep learning nerd of the project. I like to integrate artificial intelligence into hospitals to make better, simpler diagnostics of heart diseases. Now, enough about us, and let's talk more about this project. So, there's this concept that we really like to emphasize in here, which is the notion of computational collaboration. The notion that artificial intelligence systems, when they're in a symbiosis with humans, can create truly beautiful products whose value is far greater than the sum of all its individual components. With that concept in mind, we created OrchestrAI. OrchestrAI is a module that can compose, create, and even improvise music. Now, as a part of this pipeline, there are two modules. The first one is the improvisational module, which can improvise music on the fly. And the second one is a neural module, which can compose tracks. Now, Sarthak here is going to explain much more how we can improvise music.
So before I start talking about the improvisational module, I'd like to spend some time delving into what exactly was our inspiration for the project. Why did we decide to do something this crazy? So 10 years ago, I used to play the pianica, and I was a little budding virtuoso, as you can. So as you can tell, I like composing melodies. I like getting them done. But when I would try and play this with other people, I was terrible. I had no sense of tempo, and I could just not play with other people. And that actually demotivated me and caused me to quit playing a few years later. But even if you've been playing an instrument for the past 9 years, like Aditya, you still have difficulty in finding other people to play with. And it's always a matter of coordinating with other people or finding the people with the right temperament, people that you can just jam with and have fun with. To address this need, we created OrchestrAI. And to fundamentally capture the essence of this, we created the improvisational module first. Now, the improvisational module is pretty simple, and it consists of 3 different steps. The first step is a system to transfer high-quality, continuous audio data from our violin to a laptop to do processing. Now, this is where we had to get creative, because it turns out it's actually really difficult to get audio data that doesn't degrade over time. So we tried this with Arduino, and we tried this with studio quality microphones. And our audio was just degrading, and we couldn't do any good processing with it. So we literally hacked the most unexpected thing, which was Apple's EarPods. So you know the microphone on EarPods? It turns out that by duct taping it, literally duct taping it underneath the bridge of the violin, and then connecting the EarPods to the headphone jack of your laptop, you can actually get live, continuous, high-quality audio data that can then be used and processed and manipulated with. This is quite cool. We weren't expecting this. The next part of the pipeline involves a way to convert the analog data from the microphone to digital data, convert the digital audio data, the continuous audio data into smaller samples, each with just 1 or 2 notes. And finally, applying fast Fourier transforms on the notes to convert it from audio frequencies into the corresponding textual representations of notes. Now, the most challenging part of this was to find the right sampling frequencies, because when you're playing a violin, one of the common techniques is to actually vary the tempo to make it sound more interesting. And we accomplished this by basically comparing the average distances between amplitudes of different notes. And by averaging these distances, we managed to calculate a rough approximation for what the sampling rate should be. Finally, having converted these audio samples into a continuous stream of text characters, we then mapped these text characters into an accompanying output sequence of text characters that we know sound good because of music theory. We accomplished this through the help of an AI expert system, which you can just think of as consisting of many different rules and Boolean expressions, heuristics, things like chord progressions, musical scales, harmonies. With this knowledge, given a sequence of input notes, you can make good predictions for what the output should be like in jazz. The result, and Wolfram turns out to be really good at this particular part of the process. Because of the new features introduced in version 11, visualizing the output and doing the signal processing, all of that is a breeze. And you can really visualize the output of this as MIDI files. And these MIDI files can be played back as many different instruments, which we will show in the demo from MHAX.
Sorry for the bad quality. We recorded this on stage, but here it is.
Well, some things are much better shown than said, right? So, onto your own play.
So basically what's happening here is you see our improvisation phase. So this is the first phase of our two-stage pipeline. So here, in real time, we generate music to complement what Aditya is playing right now. So based on music theory, based on what notes go with what notes, what chords would look good, this is what we're doing right here in this stage, and this is happening in real time.
Now, one of the limitations of this approach was because of the 36-hour deadline, our accompaniment was monophonic. This meant that you could not have multiple notes playing at the same time, or you could not have rich depth into this. This is something that we addressed with the help of a neural network, which Ralph will talk about in more detail.
Definitely. So let's talk about the neural module. I was very interested in how we could improvise music right on the spot, but there's something that really fascinated me about artificial intelligence. Can you make neural networks compose and create music? So that's what we try to accomplish in neural module. So first, we got recurrent neural networks and trained them on 150 years worth of music. How do we actually input it as music in a neural network, you may ask? Sorry, back? Yes. We use a format called MIDI, which literally contains notes for how long they're being played, their volumes, and their amplitudes. And with this, computers can actually read those kinds of notes and then understand how they sound like. So we basically convert this into text and pass it in to the CAR RNN, a recurrent neural network module coined by Andrew Karpathy at Stanford. So Sarthak, if you want to go for the next one. So this is the architecture. So it basically uses a mechanism called backpropagation over time in order to understand how data is structured over a temporal dimension. So in other words, let's say you have Sweet Child of Mine by Guns N' Roses. You know, there's a really good guitar solo in the middle, followed up by a very upbeat chorus, right? That's the way the music is structured. So by understanding the way music is structured over time, you can kind of deduct how notes would fit in together in a somewhat euphonic way. So just to get into more detail, the way the network is trained is by literally inputting some character at a time step and having the network predict what's going to be the next input. So given t, predict t plus 1. You train it over the huge corpus of data that we had on Beethoven symphonies, Bach violin concertos, everything you may imagine about classical music, and we did it. But turns out that in the same way that humans have different musical capabilities, artificial intelligences also compose different quality of music depending on the architecture and the way they're trained. And the CAR RNN didn't do really, really well in this domain. Sometimes they would cram literally 100 notes in 10 seconds just to stay quiet for 30 seconds. So even a guy who knows nothing about music could play, almost the same as it. So then we contacted this guy called Hexahedra. He has a very good blog on neural networks for music. And we thought, can we actually learn some music theory structure in order to make music more euphonic, in order to make music sound better? So that's what we did. So enter the biaxial recurrent neural network. In the same way that you can learn structure over time using the character recurrent neural network, this neural network creates a whole new note axis in which you can encode how different notes and different chords relate to each other. So we had to make some changes in the input pipeline as well, encoding information about the previous states, next states, which chords are played, if a note was being held or only strummed. But if you guys are really interested in the details, you guys can just check our GitHub page, they're all there. But for the sake of brevity, you would first do a backpropagation over time, as you can see in those recurrent layers here. So you can understand temporal structure. And then here, you do backpropagation only in the note axis, giving you understanding how those notes relate. So now, let's see how they sound like, because they basically can output some text sequence in MIDI, and then we use a Wolfram language to play these many different instruments. So this is the piano. It sounds artificial, right? It sounds musical, but still doesn't sound human. It's like a whole new form of artificial intuition. And here's the cello. And finally, my favorite composition by this neural network. Now, it's worth mentioning that those neural networks created those melodies all by themselves. We didn't have any supervision in this process. It's pure computational creativity. So it means that those networks are actually able to understand something very fundamental about music itself. But what really is music, Sarthak?
That's a great question to ask, and that's a tall order to answer. So before I started this project, I hadn't touched music for a while. And with my experiences with the pianica, I thought music was all about rules and how you improvise within these constraints that you create for yourself. Because I was so used to playing non-euphonic notes, I thought that this was it, that a musician basically had to learn all the rules and create something out of that. Over the course of doing this project, though, I realized two fundamental truths: that music has several different levels of abstraction, and that at the end of that abstraction tree, music is all about connecting with human beings on an emotional level. What do I mean by that? Why do you like listening to Bohemian Rhapsody by Queen? Is it because it plays at 143 beats per minute? Is it because it's in the B-flat minor chord? Is it because of the way that the guitars seem to have this syncopated rhythm? If you're interested in the structure of music and how that influences you, yes, but that's not the only reason. There's something more. So could it be because you're interested in, because Queen made the song, and Queen are one of the most famous bands in classical rock, that this is a defining song in classical rock, and it's influenced many musicians and many other composers. And it relates to a time period in history. Well, yes, that explains part of it. That explains how we as human beings relate to culture and how music can serve as a bridge to that. But let's take it a step further. Could it also be because Bohemian Rhapsody is an emotional roller coaster that it cycles you through all these emotions, from anger to despair to hopelessness? And by the end of it, you feel like you know what it means to be human. And this, as artificial intelligence researchers and as technologists, we see we hear this discussion about the contrast between artificial intelligence and human intelligence. But as humanists, we believe that this distinction is quite arbitrary, that what we're all trying to do is discover the fundamental principles of intelligence. And having discovered this, incarnate this, whether it be through man or through machine. And we think it's really quite beautiful for a human being to be able to compose something, inspire an AI to come up with something completely unexpected, have that inspire the human being to create something even more beautiful, and just create beautiful music together and just explore your creativity in a way that has never been possible before. We think this is quite fascinating, and we were quite in awe when we were having late-night conversations about this during the hackathon. But we also felt like there was something more to this, that this could be expanded to other fields. So, Ralph?
Definitely. So when I was working on this project, I couldn't help but think, cool, we're making those really cool cooperations between artificial intelligence and humans and creativity. But couldn't we apply this concept, generalize it to literally every single branch of knowledge? So I just literally had a flashback into back when I was 6 years old. My aunt was absurdly good at art. She could name anything, she could draw it and paint it in perfect detail. And I was always awful at art, but I know that I could sit down with her in the kitchen, and I used to be really passionate about animals at the time and be like, Auntie, can you draw a wolf for me? Can you make it better, bigger, edgier? And no matter what I told her, I would always have this beautiful picture of an animal right in front of me, even though I didn't understand anything about art whatsoever. Because, as Sarthak said, my aunt had all this knowledge. My aunt had all the knowledge over all those layers of abstraction. Now, what if we can take this concept of a very intelligent artificial intelligence expert system aiding humans into a much more compelling problem? Let's take medicine, for example. Being from Brazil, people suffer a lot from lack of medical conditions. Matter of fact, it takes almost 10 years to train a doctor in there. A lot of people suffer a lot from the diseases. So what I was thinking, couldn't we get material literally from Yale, from Emory, from Harvard, from Mount Sinai, some of the best medical schools in the world? Create artificial intelligence modules in there that can look at images of, that can literally look at medical imaging and detect cancer lumps in those, or even be able to look at images of hearts beating, and detect diseases way ahead over time, looking at patients' longitudinal records, anything medical, you name it. And what if you could get all those modules and give people in the world access to those? Give every single doctor in those countries access to a medical facility and a team of surgeons worth of knowledge so they can affect much more people with it. And to conclude this, isn't this a world that we want to live in? A world in which our junction of artificial intelligence can make us smarter, more talented, a more creative, and more efficient society. Thanks a lot for being here, people. If you guys have any questions, we're all ears. We're going to be here for a while. Thanks a lot.